In today's video, I have brought you a very nice problem. Here is the following information. What is the smallest value of n as a natural number such that there are x1 through xn as integers? With this following equation, we have x1 square plus x2 square and all the way down to the xn square equals 2011 to the 2011 as a power. Okay, so in order to make it more simple to work on, we are going to use number theory as a tool. Okay, so let's go through the solution. So the idea which we are going to use here, so we are going to reduce this one to the mod something, mod number, which makes this one more reducible to the smallest value possible, corresponding to the right hand side of this equation. So we need to reduce both sides of this equation to the mod n. But which mod n we are going to use here, we are going to figure out. First of all, if you take a look carefully at the squares of this one, so every individual term has a square here. So which means if you are going to check obvious values of n through, if you are going to make the chart by checking each value of this one to see what's the mod this one. So as you know, for the square, if you reduce this one to the best number we are going to choose as a mod here, we are going to reduce this one to the mod 4. Okay, reducing mod 4. Okay, because mod 4, if I'm going to use the chart here, we are going to see what the values are. Okay, so let's check. Let's first of all are going to make the chart, check the following values: 1, 2, 3, 4, 5, 6, 7, and so on and so forth. Okay, for the first value, because we have natural numbers, for the first value is given to 1 here. Second value is 4, which is 0. 3 square is 9. 9 is 1 more 8, which is 1 as an odd number. 4, which is 16. 16 0. The other one is 1. The even 0. The other one is 1, and so on and so forth. So if you take a look at each term, odd term has 1, even term has 0. Okay, which means if you put then any integer, you square it and you apply the mod 4, you get 0 or 1. When we have odd number, you get 1. When we have even number, you get 0, as we see it in the chart. Okay, so I'm going to do the same thing for the right hand side of this equation. Okay, so for the right hand side of this equation, since we have a huge number here as an exponent, we are going to use the Euler theorem. Okay, so Euler theorem, what's the Euler theorem says? If you have a as a base, phi to the n is a congruent to 1 mod n, but which condition? When we have GCD of a and n equals 1, which means we have a and n are prime numbers, a not divide n. We have to have this condition in order to apply this Euler theorem. Okay, so in order to apply the Euler theorem here, we are going to calculate phi of n first. There is two ways to calculate this one. N is multiplied by 1 minus 1 over P1 is multiplied by 1 minus 1 over P2, and all the way down to the 1 minus 1 over Pk, like this. Okay, prime can divide 4, so if I'm going to use number 4 here, we are going to pick up only prime numbers which divides number 4. We know only number 2 is a prime. Okay, so here we are going to calculate. We have 4 is multiplied by 1 minus 1 over 2, like this. This one is strictly given as half here is multiplied by 4, which is 2. Same thing if you are going to calculate this one in different way. So we are going to check how many terms are relatively prime to the 4. We have number 1 and number 3. Okay, so which is going to give us the same result. Okay, so I'm going to use this result in order to solve our problem. So a will be replaced with 2011, like this, to the phi of 4, which equals 2011 to the 2 is a congruent to 1 mod n, which will be replaced with number 4 here, right? Remember, we have two levels here, okay? The first level we are going to reduce to the mod 2 as an exponent. The base level we are going to use the mod 4. So that's what I have here. So which means we are going to check. We have 2011 is a congruent to 1 mod 2 because we already calculated phi of n equals 2, okay? So, but remember here, we know 2011 equals 2008 plus number 3, okay? 2008 it will be the same as 4 is multiplied by 502, okay? Plus number 3. If we are going to reduce this one to mod 4, I will get the 3 as a remainder, okay? So which means I get 2011 is a congruent to 3 mod 4. So now we are going to apply the Euler theorem on this one. Put this one on the form of the exponent as we have here. So we will have 2011 to the 2011 is a congruent to 3 to the 1 mod 4, okay? Because we have two levels here. We have first level 2011 to the phi to the 4 will be reduced to the mod 2. The base level it will be reduced to the mod 4. That's what we have applied here, okay? Yeah, it gets us to this one. So we get 3 as a remainder, okay? If you go back to the chart, we have m squared, we have this set 0 and 1, okay? So what we have done here, we have reduced both sides of this equation to the mod 4, okay? We get the right hand side of this equation as a remainder number 3, okay? We are going to check with this chart about the remainder. So in order to get the same remainder, we are going to calculate, we are going to check where we can have the sum of the remainders is given as 3. As we have this sequence, this one it will be put on the form of the sum. So we are going to add the first term and the second term and third term and so on until you get number 3 here, which means this one is telling us m must be equals 5, because this fact that we found is giving us a strong information about the left hand side of this equation, okay? So in order to have the same remainder as an equation, we have calculated term by term. It get us to number 3 as a remainder, okay? But we can get the same remainder if we calculate other numbers, but the question is asking us to calculate the smallest value of n. So the smallest value of n is start from the beginning, not from the mirror, not from the end, okay? We are going to check from the beginning until you get a remainder 3. So as we're starting from number 1, you get number 1, 0, 1, 0, number 1. If you calculate these 3 terms, you get number 3, which means the value of m equals 5 is giving us this remainder number 3, okay? Now we found the m equals 5. How we know? This one is going to be written on this form, okay? We know 2011 equals 2 times is multiplied by 1005 plus number 1, okay, like this. So if I'm going to put this one on the form of exponent as we have here, so I will have 2011 to the 2011 equals 2011. By replacing 2011 with its value, I get here 2 is multiplied by 105 plus number 1 equals, this one equals 2011 to 105 to the 2 square as an exponent is multiplied by 2011, like this, okay? So we are going to check 2011. So I will have 2011 to the 211 equals this term. 2011 it will be replaced with number 1 square plus number 1 square plus 3 square plus each square plus 44 square, like this. Okay, so what I'm going to do now, I'm going to distribute this one. If you distribute this one like this, okay, it gets us to every individual term, you get square. After this distribution, you will get x1 square plus x2 square plus x3 square plus x4 square plus x5 square, like this. Okay, now we transferred this expression into this expression, okay, with n equals 5 as the smallest value that we have. Okay, so I have done this problem. If you are interested in this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in the next video. Bye.